I'm a project manager for IoT technologies at Deutsche Bahnn. And right now, we are right at the start of a major LoRa rollout in Germany, all across our train stations. And one of the first main cases, one of the first use cases, is going to be the monitoring of our station clocks with LoRa. And today, I would like to show you how we do it, how we got there to what we do, and what exactly we monitor in our station clocks with LoRaWAN. So, very shortly, within the next 2 years, 5,000 of our station clocks, those clocks which you can see at train stations all across Germany, are going to be monitored with LoRa at German train stations. This means, of course, that we have to roll out the whole LoRa infrastructure as well as those clocks with LoRa modules. And the main purpose of this is to monitor those clocks so that we know straight away when a clock has a defect and we can send out a technician to fix it. Plus, we can also talk to our suppliers with the data we get from the clocks to even improve the engineering of the clocks and to avoid defects in the future. And this is an overview of the sensors that we use to monitor our clocks. So they're like magnets on the clock hands, so we can check if the clock hands are stuck or if they move incorrectly. Then there's a light sensor in the clock to see if the lighting of the clock works fine. There's also a glass breakage sensor in the clock, and we use this to check if vandalism is happening. You see, if there's like a soccer game, a football match, and somebody might be throwing stones against the glass of the clock, we will know right away due to this little sensor. Then we have also got a temperature humidity sensor in the clock to see, for instance, like if it's raining and water got into the clock, we also know right away, oh, it's a bit too humid in there, let's go and check. Plus, we check power outage detection. So this is basically what we are monitoring in those clocks. And then, of course, this data is transmitted via LoRaWAN to the LoRa gateway as usual, and then there's a whole back end behind it, the network, the application server, and the whole IoT platform with all the rules, so that we can have that we do have maintenance orders in our SAP system straight away. Because now, if one of our clocks, if it breaks, it takes some time till we or our customers, if it's realized that the clock is defect. And then somebody calls, hey, the clock has to be fixed. And then somebody is sent out to go and check what has to be fixed. Like spare parts might be missing, then he has to go back and he has to go to the clock again with the correct spare part. So it can take some time. And now, within seconds, we are going to be having the maintenance order in SAP, which can tell us, okay, this part of the clock is defect, so please send somebody out, go fix me, which is going to make it a lot more efficient. And yeah, you're probably thinking now, how did we get started with that? Why the clock? And how did we start with this big project of rolling out 5,000 clocks with LoRa? Initially, we just took one of our clocks and went to a hackathon in Berlin, close to our offices. And there, the clock was fitted with the very first preliminary prototype. The very first proof of concept was done to remote monitor our clocks. And yeah, we even we won one of the awards at the hackathon, which was very nice. And then in the next phase, which started a bit more than a year ago, we did a proof of concept where 50 LoRa clocks were rolled out at train stations all across Germany, in Essen, Berlin, Zwickau, Freiburg, and those clocks were partially developed by one of our internal suppliers, and some others were being fitted with a sensor solution by Relayer, an IoT company based in Berlin. So like then we saw, okay, this solution, it works when it's out there, like in the field. Yeah, and those clocks have been ticking out there for about a year now. And here you can see the installation. So there were like our technicians were sent out, and they included the monitoring kits and the clocks, as you can see. And then we got all the data from the clocks. As you can see here, we can see the messages we received from time to time, and we got the information about the vibration, the temperature, the pressure, and the light. So all the vital data of the clock was transmitted every few minutes, which was quite successful. We also had dashboards, where you could see where in train stations the clocks are actually located. And so this is what we did in the very first phase of our project. And now the big rollout with the hardware and all the business processes behind is starting right now. But of course, we don't intend to stop here, but we intend to go even further and include additional features that are going to be beneficial for our clocks and our business. So right now, we are doing a concept study on time syncing clocks with LoRaWAN. Usually, those clocks, they either have a master clock somewhere, there's a master clock, and then there are cables which are linked to the clock, and that's how the clock gets a time signal, which is quite costly because you need all the cabling, and so it's never cheap. Or you can have DCF77 receivers. You can see the receiver here, and I also brought one. Those are those receivers, which are quite common for clocks. And the big disadvantage of those receivers is that, firstly, they do not really work if a train station is underground or if the roof is not very good to get the signals through. LoRa works a lot better than DCF, for getting through roofs, for building penetration. And plus, there are also quite a lot of receivers that get ripped off due to vandalism or so. So it's using LoRa is also gonna be beneficial for both quality as well as costs when doing time syncing with it. So this is our next endeavor where we are doing the concept studies right now. And so no more master clocks, no more DCF receivers. And I would like to show you a little bit of a live demo. We've got a demo clock. It's like a real clock, just transportable. And so it contains a clockwork. There's a low-pi board in it, and also sensors I showed you. And what we can do, one thing we can do with this clock is that we've got a light sensor in there, and we can cover it. And then we've got this display. And basically, there's going to be an error. Okay, now no more light because we cover the light sensor. And then a message is sent straight to our SAP that the lighting is not working anymore. This usually happens within seconds when I'm in our company network. So it's basically like you cover the light sensor, and then like you receive the message in front. There's like, we are using Node-RED and Grafana behind it, and AWS IoT for the chain till we get into our SAP system. So this is something we did with the clock. Plus, we can also do the time syncing, because as you can see, like the clock, there's no DCF receiver. It's like loose. And it's also not like on a cable. So what we do is like we can boot the clock, and then it's joining the LoRa network, and then it should get the correct time signal and set itself to the correct time. Yeah, now it's still joining LoRa, but it should get the time signal quite soon and should be at the correct time very shortly. Yeah. And what else we are doing is like another feature that we intend to include in our clocks very shortly is the so-called PAX counter. That is this device. And this is like basically it's a counter to count the persons around you. So what we do is, like you can see on the screen, like we do a scan of Bluetooth, low energy, as well as MAC addresses. And then we can, we've got this estimation, how many persons, how many people are in the area, which is also quite useful for train stations to like get a general feeling of how many persons are around, which persons are like in which area of the train stations, and at what times, like which areas of the train stations are the most frequently visited areas. So currently this device is like a prototype for that. It's based on an ESP32. And right now we are starting like an investigation how to include this device and these features into our clocks. Because this would mean that with our clocks, we could also count how many persons are around, like what's going on in our train stations. So this is also pretty cool. And yeah, as you can see, our clock, it got the LoRa signal, and it set itself to the right time. You can see like the shorthand, which is at 2 o'clock now, and the longhand, which is at 20 past 2. So what this clock did now, it joins the LoRa network, and yeah, it got the downlink with a time signal. So no more DCF receivers. Yeah, so this is what we are currently doing with our LoRa clocks that are being rolled out right now. And yeah, and of course, like the TTN community is also something that we are very much involved in, and we've been involved in right from the beginning. Like we installed one of the very first gateways in Berlin, here on top of the main train stations in Berlin, and yeah, and registered it with TTN community. So it was open to the whole community, TTN community of Berlin, and meaning this, like we, in the beginning, because we wanted to get the technology a bit better, and we did some coverage tests with LoRaWAN, and it was really awesome. Like when you go outside of the city, we achieved 44 kilometers of coverage till Brandenburg an der Havel, and like inside in the city, 7 kilometers are also achieved quite easily. And plus, like going underground is also pretty amazing. Like we did some range tests in Berlin in the main station, which goes quite deep, and there's like no cellular collection at all. If you go into the corners very deep in, like where still like trains are like going, but we had LoRa Connect, which was pretty awesome. And with this gateway, which we have provided to the community, we hope to encourage other smart city projects in Berlin, and to support them with the LoRa gateway and get people to experience the technology a bit better. Plus, we have got the TTN Berlin mapping taxi. There's a taxi driving around Berlin all the time, which has got a TTN Adeunus tracker inside. So it's driving around and tracking the connection in Berlin all the time. And so the coverage of Berlin is getting mapped in TTN Mapper quite well. Thank you very much. Of course, this is just the beginning of our journey. The station clock is going to be the very first device, which is going to communicate via LoRaWAN in our train stations later on. There are going to be lots of other devices following. For instance, the geolocation feature, which was introduced at the conference, is going to be of extreme interest for us to do asset tracking with LoRaWAN, and also LoRaWAN in combination with energy harvesting. We regard as extremely beneficial for us, for instance, for devices which are not powered and which also tend to disappear or to move quite a lot, like fire extinguishers or like doors where we have to be sure that they are closed and not open. So I truly believe that with the progress of the LoRa technology, there are going to be like an extremely large amount of use cases for us at Deutsche Bahnn in the near future. And if you want to stay tuned, if you want to stay up to date what we are doing with our LoRa network, please just follow me on Twitter at Olga Willner. Thank you.
Okay, we have time for a few questions. Not too long, but
Hi, first congratulations on the work you're doing. My name's Simon Gehren, I'm from TTN Switzerland. I think you met Gonzalo. So what I'm very interested in is, now you have all these clocks out and we're building the community network. Are you going to allow public-private pairing? That's what Johan said, on all the 5,000 clocks?
Not like with a network that we are using for production purposes, it's a bit difficult. But there are definitely going to be TTN community networks around at Deutsche Bahnn as well.
How was your, because we're discussing with other people, and how our problem sometimes is that the IT departments are reluctant to even allow the community gateways, even if they have two different gateways. What is your advice on that, talking to big companies such as Deutsche Bahnn or similar companies within Europe?
Well, like we are the IT department,
That's good.
And for us it's very important to get involved with the community,
Yes.
because we firmly believe that like smart city projects, they require a lot of data, they require open data, they require APIs, and that we should also, like as big corporations, we should also be the ones like who provide the community with either, be it a LoRaWAN gateway or with the data they can use, and it's beneficial for all of them. And I believe like with the gateways, well, of course, you don't have them in your company network, but you have like a different network for such applications.
Yeah, but the public-private pairing is a no-go then, sadly.
It's probably not going to be the very first thing.
Too bad. But
Yeah.
thanks anyway for the effort. It's great.
Okay, one more question. Yeah, at the back.
Hello, I'm Steve from Milan. I'm not sure if I missed that, but how many gateways did you use for the project?
And the gateways are being rolled out right now, and the calculations, how many gateways are going to be at each train station, are still like work in progress. But it's definitely always going to be a few gateways per station.
A few.
Yeah. I mean, at least two, like to have backup. It kind of depends on the size of the station.
Thank you very much.
Like for the proof of concept, I think like at the smaller stations, it's definitely two, and if it's a bigger station, maybe 4 or 5. But you need some sort of redundancy. In particular, later on, like firmware updates are also going to be of interest for us. And then, like, you both need the downlink and the uplink channel. And then it's going to get even more relevant how many gateways you've got.
Okay, thank you. I think we can give her a round of applause again.